morning, and the topic, as Kamal said, is on the space technology for societal benefits. So, as you all are being able to make calls from a cell phone, locate yourself through an online map, uh, the vegetables you eat, even the filtered water you drink, are just some of the areas where in our daily lives we benefit from the space technology. So if we wonder that the space exploration impacts how it impacts our life, if you see in every aspects, if you talk about the environment, if you talk about the infrastructure, the gadgets we have at home, all these, if we look into this somewhere or the other, the material which has been developed, they are the outcomes or relation to the space technology. So more than 50 years of human activity in space. The first satellite was launched in 1970s. So first activity, I mean, since these 50 years of human activity in space, we have, it has produced societal benefits in terms to improve the quality of life on Earth. The first satellite, which was designed to study the space environment and test initial capabilities of the in Earth orbit, it has contributed to a critical knowledge and capabilities for developing subsequent satellites, both in terms of communications, positioning, and even for weather forecasting. And it has initiated economic development of space and overall the country of the earth. The features economic development across the countries. Year after year, it has delivered high returns of investment. The challenges of space exploration have sparked new scientific and technological knowledge of inherent value to humankind, and it has led to a better understanding of our universe and the solar system in which we live in. So, space technology has created both tangible and intangible benefits for humanity. So, tangible benefits include all the innovations which has been done related to applications and benefits resulting from the direct investment in these programs, in these space programs. It is like we can say it has benefited in terms of the weather monitoring systems has improved over time, natural resource management, communication. It is able to connect from one place to another. We are able to connect to people, navigation, and also the offshoots of these innovations have resulted in the use of these materials or any kind of engineering designs which have been evolved in the exploration of space has resulted in spin-off technologies, which is now being used in our homes, in industries, in medicines, healthcare sectors, and the non-tangible benefits or intangible benefits, which includes the enriching of the culture, the inspiration to the citizens, and building of mutual understanding to address global challenges and international cooperation among the space faring nations. So, and national security. So these are the major sectors in which, if we can broadly summarize, where the space technology has impacted the humans in the different spheres of our life. The space sector's value or to life, in a nutshell, is very difficult to summarize in a very short duration of 1 hour. So as we saw that the space sector has provided us accurate weather predictions and warned us about recent cyclone, which you saw, the Biparjoy cyclone, which is there, or the previous cyclone. So it provides us an warning, impending warning, warns us about these significant cyclone storms. They monitor our climate every day, helping us to track increasing rates of climate change and its effect. Then it is also helping us to provides us an effective medium or the tool for activities related to land, water, environment, and the atmosphere for sustainable development. So they are best used in, we'll showcase few examples where space application has been best for monitoring, management, planning of the global natural resources for sustainable development through the use of the space-based observations or satellite images in coupled with the communication satellites and the navigation satellites. So it has also helped us in you know, analyzing, monitoring the impacts of the climate change, like the sea level rises, or the shrinking of the Aral Sea and the sharp decline in the Arctic sea ice extent, how much it is there, what is the impact of the environment, what will be the impact of this into the future, can also be predicted using modelings and the data which is provided with satellite-based observations. Measuring of the pollution in the atmosphere. Nowadays, we are frequently impacted by the pollution in many parts of the country, either due to the dust storms or due to the anthropogenic activities or due to the agriculture burning. So what is the impact of this into the health of the people, what measures needs to be taken, what policy decision needs to be taken. It aids in all this by providing an accurate measurements, and also in protecting wildlife, animals and their habitats by monitoring the land use land cover changes, and it helps in promoting the preservation of land and natural resources. So Earth observation, it provides information related to the various aspects, and it helps us to basically manage the land and water resources in terms of both monitoring and monitor and manage these resources. It provides us various layers of information related to the topographic information, water, where is the surface water, where is the ocean waters, I mean, entire drainage systems, the soil moisture condition, the vegetation present in the land surface, the different types of vegetation, the soil temperature, all these input layer information can be derived from the space-based observations and can be used for analyzing. So in terms of, if we say Earth observation provides information and support to all these applications, the varied applications on the Earth surfaces. To list a few, if before this, let me tell that the space technology primarily refers to three areas. One is Earth observation satellites, which provides the images, pictures, which is captured in three specific regions in the optical remote sensing optical region, which comprises from the wavelength range from 0.4 to around 2.5 micrometers, which ranges from the visible and the near infrared region. Then it provides in the thermal infrared region, which is in the range from 8 to 14 micrometer, which relates to the heat or the temperature information about the land surface or the water surface features. And the third area from the Earth observation satellites is in the region from the microwave region, which has a specific property in terms of it is sensitive to the water content, the moisture content, the surface roughness. So, and it also has a penetration depth. Another advantage in the microwave is it is data which can be collected both during day and night. It is an active sensor, so it can be collected both during day and night, and it is also not affected by the cloud conditions or the weather conditions, whereas the optical and the data in the thermal part, which measures the temperature in the middle infrared region, is impacted by the cloud cover, so it cannot penetrate, whereas the microwaves can penetrate the cloud cover and provide you this information. The next aspect is Earth observation satellite, covering in three major the electromagnetic spectrum. Then the satellite communication, which is used for all kind of communication applications, radio, broadcasting, and television networks. And then the navigation satellites or satellite-based positioning system, which helps us in navigation. So the Indian space program or the Indian remote sensing program has been driven by the user's needs. In fact, the first remote sensing based pilot project was the one which was carried out to identify coconut root wilt disease in Kerala way back in 1970s. And this led to the development of the various Indian remote sensing satellites. Now, varieties of instruments have been developed and are flown on the Indian remote sensing satellites to provide dimensions. Temporal means repetitive coverage is different for different satellites. And in the spatial dimensions, that the size of the data varies from kilometers to now 30 centimeters of spatial resolution. So the resolution catering is also there, and the data is being provided with the different temporal dimensions. So as we see that the satellite observations have an impact into all these applications, like agriculture, which plays a very essential role in our daily lives. And it is one of the area where this technology has been successfully used. It has been used to estimate the crop acreage. It is also used to assess the crop damage. Then crop forecasting to estimate the amount of production, crop acreage production. For forecasting the crop, there has been various projects which has been undertaken by ISRO along in collaboration with the respective departments as well as the ministries to create a database where, for example, there is a program called Crop Acreage and Production Estimation called CAPE, where for the major crops like wheat, rice, rapeseed, mustard, cotton, groundnut, bajra, sugarcane, some of these examples of these crops, one can estimate how much would be the production, pre-harvest production type, so that government can take remedial measures if the harvest is appropriate to cater to the entire country, if it is deficit or in substantial amount. So accordingly, the government can take actions accordingly. And even pre-harvest acreage estimation for production, estimation of major food grains, oil seeds, fiber crops are generated regularly. So in this connection, ISRO developed an approach methodology for effective use of this technology in the agriculture sector, and has a major stake into this. And then subsequently a new center which has been developed, Mahalobanas National Crop Forecast Center, which is located in Delhi, is carrying this work forward of developing a estimation of the pre-harvest crop acreage. Even crop damage assessment, drought monitoring, agriculture drought monitoring, soil resource mapping and assessment, land degradation, soil erosion. So by providing these up-to-date information related to the humidity, precipitation, forecast, and crop conditions, satellite-based technology is helping the farmers to manage their crops and maximize their yields. So this is one area where we see that it has been effectively used to improve the production as well as the farmer conditions where the broadcast has been given to them. Then another success story of the space-based application is the prospective fishing zone or the potential fishing zone, PFZ, which is known as more commonly known as the program, is one of the major success stories on the use of space technology for the benefit of a common man, which is a fisherman. So the satellite-based technology is used to identify fish-rich zones where fishermen stand the best chance of getting the good catch. So it uses the chlorophyll data, temperature data, and the wind speeds, which is derived from these space-based observations, and a modeling technique to, forecast the locations where they can get a good catch. And these advisories are provided in terms of the location, the latitude and longitude, which is given to a fisherman on their NAVIC receivers, which is an instrument which is being given to them, where the locations are provided on a daily basis, with reference to around more than 580 fish landing centers along the Indian coast. So what is observed is this PFZ advisory had led to an 30 to 70% reduction in time which the fishermen spend to catch the fish. And as a result, this added in saving the fuel and thus reducing the carbon emissions. And it has subsequently changed the lives of the fishermen as they get a better catch, thereby making their livelihoods more reliable, and has contributed to in saving their time, reducing fuel consumption, as I said, and they have a better income. And also it is helping them or preventing them to venture into seas in adverse conditions. So even their lives are saved because of this advisory, which is being given on a lively basis. Now it was initially started, now given by invoice. This is one of the live examples where it has changed or benefited a common man. Then ocean state forecast, coastal zones management, oil spill studies, the intertidal information which is there. So all this areas where in this technology is being effectively used. Then in terms of water resources, also in water which is one of the essential requirements of the human beings, both surface water, groundwater. So we'll be showing you examples where this technology is a complete surface water map has been generated from as an inventory for from this technology has been generated. Wetland mapping and monitoring, the mapping of the river lakes, the soil and water conservation areas. There have been many projects in collaboration with as I said, with the respective departments to highlight the use of this technology, and has been effectively used subsequently in mapping these water bodies across the nation and across this nation, and be used for better management of these water resources. Then snow and glaciers, monitoring of snow and glaciers, snow covered areas, the impact of the climate change, how much will be the runoff, snow melt, and what impact it will have on the water availability. All this is also being monitored. Then monitoring irrigation infrastructures, high resolution data sets, which is there. It is able to create an inventory and map of the irrigation infrastructures, any kind of canal leakage detection, irrigation of the watershed management. The water management and watershed management can be done using this technology. Then forestry is another area where this technology has been quite effective. Now, forest resource inventory monitoring and management. So forest cover and change mapping. And this initially it was initiated by ISRO. Now Forest Survey of India has taken up this work, and it has been effectively used by them to create the forest resource inventory, the forest type maps. They keep on updating the kind of degradation happening in forest areas, what are the different issues related, forest cover change, forest type mapping. Then also there was another project where ISRO has done for the biodiversity characterization, where the complete biodiversity of the area has been mapped in the Western Ghats, in the many regions, including the Western Ghats. So this is the example of the water resources application. So inventory of a surface water bodies, locate water bodies and delineate the networks. And these are all live example projects, and the database which is generated has been put on to a public portal, which I'll just tell you at the end, where the public portal, this data is available for the respective departments or the users to use it for a better management of these water resources. So here on the portal, there is called as a Bhujal portal, where 9,200 research structures and more than 3 lakhs of wells have been dug. Potential zones where groundwater availability, potable water is there. So that is being identified. And also the groundwater, how much it is depleting, what is there. So this kind of information can also be obtained from the satellite base, and accordingly action can be done or taken to rectify this. So in this context, An objective of creating a complete water resources information system has been created, that is known as India IIRS system, which provides a single window solution for all the water resources data and information in a standardized framework. And it allows the users to search, access, visualize, and analyze, understand, comprehend, and the contextual water data for the assessment, monitoring, planning, and development of water resources in the country. So this is a portal which is being generated and is available on the ministerial website for the use by various states for the effective water resources management. So this is the map which shows the groundwater changes during 2002 to 2008. And the areas which you see in red are the one where there is a depletion or the water has gone down, and the blue areas are the one which has gained in terms of the groundwater. And from this data, one can estimate the depletion rate, and it was found that in the north and western India, it is around 4 centimeters of water per year. This is in the area in the period between 2002 to 2008. So groundwater prospective zones also, it has also helped in remote sensing, has also helped the satellite-based observations in delineating the potential groundwater occurrences zones in a less time, which has been quite effective than the conventional methods. So under the National Drinking Water Mission, which was launched by Government of India in way back in 1986, there was an effort to provide sources of safe drinking water to around 1.6 lakh problematic villages. So under this mission, which was there, the National Drinking Water Mission, a broad groundwater prospective zones have been identified for further follow-up through hydrogeological and geophysical methods to locate potable drinking water in these problematic villages. So, and these possible groundwater sources were delineated for drinking within a radius of 1.5, covering all the habitations at a scale of around 1:50,000. And this information was utilized by the government private agencies related to the groundwater development activities. So this helped in narrowing, what helped, the main advantage was this information which was provided using these space-based observations connected to groundwater explorations and the probable groundwater prospects, thereby narrowing down the area of investigation for profile selection, sites of drilling, for planning, research structures, ultimately to address the drinking water problem in an effective manner for the common man. The space-based observations also helps in monitoring and management of the atmospheric gases, atmospheric pollutants. You can get information related to air pollution, air temperature, carbon emission gases, which is there, humidity, cloud cover, wind speed. So all these information which are effective to monitor the environment of an area can also be derived, and based on these parameterization parameters, one can derive the air quality index and then subsequently take the agencies or the government state departments can take remedial measures to improve the air quality, find the causative factors, and then improve the air quality of the region so that the people can be healthier. So this is one of the map which gives you a global level derived on the particulate matter 2.5, which is average, how much, where the pollution is more, you can get to know the trends and then find the positive factors and then take subsequent actions. Earth observation also helps in disasters. It has been quite effective to manage the disasters. As I said earlier, the cyclone prediction is very, very accurate now. In most of the examples we have seen, it has saved both human lives. Because of these accurate predictions, we are able to evacuate the people well in time and then save them from the human loss. So now this technology is well established, and we have seen in the previous also how we are able to track continuously the cyclones. Then flood hazard monitoring. This is again one of the areas where we have developed the system where the flood hazard monitoring and the warnings have been also issued. So this is there as a part of the disaster management program of the ISRO, where they have this information in a real-time data and information, and support is provided towards the management of these natural resources, natural disasters like floods, landslides, forest fires, and cyclones in the country. And this is entirely again put on this advisory, and the warnings have been issued onto the public portal, which is known as Bhuvan. The outputs, which these are there, is available there. One can look on these maps, which highlights these potential zones. So extreme rainfall events, coastal hazards and disasters, volcanoes. There are 2-3 websites. The MOSDAC is there, Bhuvan platform is there, in which the use of which one can have a real-time data information and support for the management of the disasters. Now, as part of for the urban infrastructure mapping in urban area, also this technology has certain limitations because of the spatial resolution. But now with the launch of high resolution satellites, this technology is playing a very important role in the urban sectors, specifically for creating an urban infrastructure mapping. As a part of the Amrit program, which is basically to design a master or a development plan for more than 500 cities as a part of phase 1, and then increase it in the phase 2, around more than 400 cities, adding more cities in the phase 2, is one of the major steps where this technology is playing a role to provide the base information, like a georeference base map, land use map, accurate land use map using an high resolution data for a scale of 1:50,000, 10,000 scale. Maps can be generated. In analyzing the urban sprawl, the city, how it is changing with the growing population, what is the direction of change to provide for the management part, to provide all the infrastructure support. This technology has been effectively used again as a part of another scheme, which was the National Urban Information System, which was done in way back to establish a comprehensive information system in the urban local bodies for planning, management, and decentralized governance, to produce a database of both spatial database of various levels of urban planning and decision support at a scale of 10,000, 2,000, and 1,000. It was designed so as to enable in preparation of a master zonal plans. So, and specifically for the utility mapping. So even this is one of the major success stories where this satellite-based observation is being used by the urban department, urban ministry, to develop a complete database of the major cities in the country for the sustainable development. Then another area is geology. In geology, also this technology, in fact, they start when the satellites were launched. This was one of the areas where in geosciences, where the remote sensing technology were used by geologists. The remote sensing data was basically used to initially study the structural geological features like folds, faults, fractures, geomorphology, lithological mapping. And in turn, now with the evolution of the hyperspectral data sets, where you have a large range of information, is used in mineral and oil exploration, groundwater exploration, and for tectonic studies, like a precursor to the earthquake, and for your landslide pre-warning system. So it has been effectively used. It has been also used to study the eruptions of the Barren Island volcano in way back in 1991 and 95, and a number of various studies like desertification status mapping, the earthquake precursors, coastal vulnerability due to storm and surges and tsunami, the shoreline changes, mineral exploration, environmental geology. So these are the major areas where they have been effectively used. Then, as I said, the weather and the climate, this has been and provides you the essential climate variable, some of the parameters which can be derived from the space-based platforms like the sea surface temperature, sea surface heights, air pollutants. So all these parameters which is required to understand the weather and the climate can be effectively derived from the space-based platforms. So as I said, another area where we started off long back is the natural resource management under the natural resource management program, where a complete database of the entire country was created at a variable scale from 250,000 to 50,000 on various features for land use, land cover, land degradation, snow and glacier, soil, geomorphology, vegetation, types, wetlands. And this has been used by the effective departments for analyzing the temporal changes and in terms of the identification of the wasteland areas in the country, and for effectively managing the wasteland, creating a natural resource inventory of natural resources and periodic monitoring like the soil, the land use, the land degradation, vegetation, water resources. So a complete database which is created is available on this, again, the portal which is there, public portal, which can be, and FSI has now carried forward this database and is effectively creating the forest cover maps at varied scales. Now, under the space-based information support for decentralized mapping and planning, which is empowering the stakeholders in the terms of planning and governance at the panchayati levels, at the lowest level. So a database again in this is being created in terms of the high resolution georeference based base maps in terms of land cover, infrastructure, drainage, settlement. So it is helping in creating a complete map assets. One can, in this portal, view the panchayat level data at the state, district, block for an effective management. Here, this is the complete disaster management support system, which is a single window system, again within the Bhuvan portal, where one can use it for flood inundation monitoring, the damage assessment, drought monitoring, earthquake damage assessment, cyclone damage assessment, inundation mapping, the forest fire detecting and subsequently getting the damage assessment, landslide damage assessment, and landslide hazard zonation maps can also be generated. And satellites the database has also been effectively used for reimaging the past footprints. Like we can use it to understand our past, how the terrain was, how the topography, or how the culture has modified vis-a-vis the urbanization, population, whatever is there, what was our culture, how the drainage system has changed over time, what is the positive factors. For example, this is a mapping of a complex temple near in the southern area. So one can see how the history at the past, how it was there, how that civilization was there, and how the current scenario it has changed. How the drainage system, this is where it has been able to map the buried channel, where the old channel, which is there using both the optical and the microwave data sets, one can look into, and where the buried channel, it used to flow and now it has migrated and changed with respect to the time period. So this is one portal which I was saying, the Bhuvan portal, which provides, it's a geo portal which provides a nation a seamless database on a basic raw satellite images, which is geo-corrected, thematic data sets for natural resources monitoring, management, transport network, the topographical information in terms of the digital surface model, hydrological hydrologic base information map, geology map, snow cover map. These data sets can be downloaded free of cost. They are near real-time disaster services, or services are also available. There are apps also for where the people can upload the crowdsourcing and diverse for varied applications. So this was launched in way back in 2009, and it is available where the address is www.nrsc.bhuvan.in. So this is the under that Bhuvan portal, we have this National Urban Information System, which is a web-based application which provides the database required for preparing a master plan, and urban geospatial database for 152 towns on 1:10,000 scale is available. Then, as I said, under the Atal mission, Amrut mission, which is Atal mission for rejuvenation and urban transformation. So number of cities have been mapped, where a base map of 1:4,000 scale using 50 centimeter resolution data has been generated. Then this is the Bhuvan Bhujal one for identifying the groundwater sources and creating restart structures. So for the problematic habitations where there was a problem of potable water. So using this data derived from the space observation and the analysis, the site suitability where potential water zones were identified. It also helps us to connect people. So if we look at it, it is connecting us all across the globe. The telecommunications, so satellite-based telecommunication is one of the most popular uses of satellites. So it allows to connect with people from different parts of the world through either phones, radios, internet access, televisions. And also it is being used effectively for the medical infrastructure and education purposes. So telemedicine and teleeducation. So in terms of people who are there in remote areas where there is a lack of suitable or appropriate medical infrastructures, for example, in remotest areas, in Siachen, in very, very rural areas. So this communication satellites can be effectively used for this telemedicine program, and it has started way back in 2001 and is effectively used in many parts for providing the basic healthcare facilities to the people in the remotest areas. So these mobile telemedicine units, which was designed, covers various areas of healthcare systems like ophthalmology, cardiology, radiology, mammography, general medicines, women and child healthcare. So there are a number of units of these mobile towers, which mobile telemedicine units, which has been helping to provide services in the rural areas. Similarly, teleeducation is one where we had the first satellite called EduSat, and subsequently this is providing we could provide education to the remotest areas. And other advantages, as I said, we can use it for the broadcasting, communication, and other applications. So basically, we can reach the unreached using this technology either through communication aspects, communicating with them through medicines, providing the appropriate healthcare, and the education in remote areas. So this is one example of the VRCs which has been developed in the Himachal and Uttarakhand region. And the next area where the space technology has been effectively used is the navigation. Navigation, or generally more commonly known as global positioning satellites or global navigation, is transforming the way we are looking at space. So it is basically providing us the navigation, the tools to communicate, to travel from one place to another. So it is the major uses is the location of an object, both in static and a dynamic mode, where it is. So the position information, we're able to map the geographical features with the accurate locational information, real-time monitoring and tracking of vehicle, ambulance, ships, even the mobile, the Uber, Ola services which you are using is part of this, using this navigation technology. And also the location-based services which you have on your mobile apps. You want to locate the nearest restaurants, the nearest hospitals, the nearest you on your mobile apps, on your systems. They all use navigation services, satellite system-based observations to get this information. So it is there in every part wherever we are going. Besides this, the engineers, or when evolving the space technology of space sector, new cutting edge technologies to accomplish some impossible goals, and these were attempted, and those technologies often turned out into products which we use every day. So spin-off technologies are basically a technology that was originally developed for space program and now is commercially used by the public, commercially, or by the, can be used commercially for the betterment of the people on the earth. So they are non-space applications from space programs. They have found an inroad in all. So these spin-off technologies which were developed, the materials, the computer systems, the hardwares, the other materials which was developed, has found applications in information technology, consumer goods, environmental resources, health and medicine, industrial productivity, public safety, transportation. For instance, do you know that the technology behind the tiny cell phone cameras was developed in an effort to miniaturize cameras for spacecraft? Air purifiers which we use at home is basically an ethylene scrubber developed for the International Space Station and subsequently proved capable of purifying the air on the Earth. Similarly, enriched baby formula, which was developed for the life support systems for a longer duration missions. So they discovered a natural source of an omega-3 fatty acid that is now incorporated in most of the baby formulas which is there in the market. So there are cordless vacuum cleaners. So in order to have rocks and soil samples collected on the moon, there was a lot of research based on which they designed a lightweight battery-powered drill. The motor technology was later used for the cordless cleaners. So you see, there are examples where this technology has been developed for X application and has a potential in Y. So NASA in general, which is the nation, which organization for the American space program, has developed more than 2,000 spin-off technologies since 1976. The European Space Agency has developed around 150 over the past 10 years, and ISRO has transferred more than 300 technologies to the Indian industry in the various sectors which I mentioned above. For example, the Indian space program, the technology included the flame-proof coatings, which is used for fire safety, aerogel, which is a thermal wear for soldiers to protect them from the extreme cold conditions. Distressed alarm system and search and rescue beacons have come in handy in the areas of disaster management. In areas of healthcare, there are the spin-off technology, from the outcomes of the space development. In the health sector, ISRO has developed a very cost-effective artificial limbs, jawbones, ultrasound, left ventricular assist devices, and ventilators have significantly improved the efficiency of the entire medical infrastructure. So we see that the spin-off technology is there everywhere. It is like it's in the fuel cell engine, biosensor to test the pathogens, algae-derived ingredients, water mapping technologies, right? chlorophyll meters, which was designed, is again the simple thermometers which are there, infrared based thermometers, again are the outcomes from the space technology. So medical technology, which has stemmed from the space station robotics designed for the International Space Station, is actually led for the early diagnosis and treatment of breast cancers by providing increased access, precision, and resulting in a high accurate and minimal invasive procedures to cure it. So if I want to summarize the anything, I say space technology has found inroad into all areas. Some are, as I said, it also has helped in the international cooperation. We are looking at the entire world as one. And we work together. We forget about the boundaries. So these are some intangible benefits where all countries come together, look at the Earth as our home, and try and strive to make it as a better place for and better environment to live on. So space technology, if I say so, provides the right information in the right format at the right time to the right people to make the right decision. So with this, I conclude. Thank you so much.